Hey guys, I'm Khalid.
Hi, I'm Eriq.
Hi, I'm Ashley, and we all develop Foodle.
What exactly is Foodle? Have you ever been hungry, looked in your fridge, and was unsure of what dish to make with your ingredients, or ever felt too tired to go food shopping? Foodle lets you create delicious meals using the ingredients you already have at home. You just need to enter a minimum of 5 ingredients into the search bar, and the app will provide you with recipes based on the ingredients you have. Foodle was built on the premise that cooking every day should be simple. Most recipe applications and websites require users to already know what they want to eat, to search for that recipe, and then buy the ingredients. This can be too time consuming and requires a lot of planning and preparation. Foodle cuts down the time needed to plan by using the ingredients already available to the app user. We believe that Foodle will simplify recipe searching, keep food spending down, and help reduce food waste by utilizing ingredients the user has at home. So, how do you use Foodle? To search for recipes, simply type down your ingredients in the search bar, click Add, and your ingredients will pop up above the search bar. So let's add some ingredients. We'll add sea bream, olives, and garlic. As you can see, the search button is currently grayed out. The user will need to add a minimum of 5 ingredients, and when there are 5 ingredients above the search bar, he will be able to click search. So let's add 2 more ingredients. We'll add red pepper and tomato. At the moment, search results is populated with random recipes generated by the API. Once you click the search button, this will be populated with recipes based on your ingredients. So if we scroll down, we can see that these are all randomly generated recipes. And now that the search button is able to be clicked, let's search. You can scroll through the list of recipes and click on whatever you fancy. Clicking on a recipe will take you to a page called Recipe Information. So let's scroll down and click on the first one, called Roasted Sea Bream. Here you will find details such as key points and any further information needed to make the dish. So here is the key points. There's the ingredients, summary, steps, dish types and wine pairing, as well as full instructions. If we scroll back up to the top and click the back button, it will load the same recipes that was given to us when we type down our ingredients.
Some of the technologies we use to help us manage the project were Git for version control of our code, Google Meets for meetings and catch-ups. We use Slack for communication and collaboration. We used Trello as a Kanban board. Here's an example here. We also used Figma for mapping out our build. And we used Jamboard as another collaboration tool.
The main color theme of Foodle is green. The psychology behind green is that it evokes a feeling of abundance and is associated with refreshment, peace, and rest. The main design layout of Foodle is modular, as we wanted a clean, structured layout to make scrolling and choosing easier. We used Figma to design our initial concept and worked from there. We wanted the search bar to be the first thing the user sees, as this will prompt them to enter their ingredients, and to also show that this is the main concept of our app. We have implemented user-friendly styling in our app, such as graying out the search button and changing the cursor to band circle on hover when minimum ingredients threshold is not met. Once the ingredients reaches the minimum threshold, the search button is clickable and changes color on hover. So let's add another ingredient. There it is, it's changed color. The add button changes color on hover as well and when activated. So let's add one more ingredient. Here it is on hover and clicked. The chips delete button also changes its color to red on hover and deeper red when activated. Here is chips delete button on hover and activated, on hover and when activated. The design and layout of Foodle is responsive. Sizing and number of column changes when viewed through different viewports. This was achieved by using SAS and media queries. Here is Foodle when viewed through a phone screen. When adding chips, and when clicking on recipe info. Here is Foodle through an iPad. When adding chips, and when clicking on recipe info. We chose to use Sass as the fonts, colors, and size variables needed to be consistent throughout the app. Importing partials was the easiest way to keep this consistency. Creating variables is a lot easier in Sass than CSS. Partials made for a clean code, and when thinking ahead, if we were to add extra fonts and colors, it's easier to keep everything in one place, separate from each SCSS file.
So the search bar component, which is one of the main components of the application, is where a user enters ingredients and searches for a recipe. So how it works is a user would enter various ingredients. Just like so. Now these ingredients here have been taken and converted into chips. The reason we've done that is because it's easy to use and it's also easy to remove one ingredient. Now once these are passed through, they'll be passed through as an array and sent through to the API. So as you can see from the top, we're handling and managing state from the top. Our value here is the value that's entered into the search bar. We've got the loading state, and also we've got the ingredients, which is an empty array to begin with. And when the user enters ingredients, it's saved as an array in this state here, ingredients. Now you can see the handle submit function, which is checking for how many ingredients have actually been put into the ingredients array. Here it's saying that it needs to be more than or equal to 5 before it sends off for the API request. If it doesn't meet that condition, then an alert will pop up saying you need a minimum of 5 ingredients. This is where the handle items are taken in, where each item, which is basically the value that's entered into the input or the search bar, is added on into the ingredients array. And here you can see further how we go about deleting the chips using this function here. Here we've got the form where the actual text input field is. As you can see, the value that's been extracted, and we are then setting value whenever that target value changes.
So I want to talk about the search results component, which comes directly after the search bar component and after a user has made a search. So we see this is, a central hub where we update state multiple times and pass in props to the relevant children components like the recipe card and the recipe info. So if we have a look at the code in place for this component, so at first we're passing in the results prop, which is basically the data, and we're saying if results is truthy and results.length is less than 6, which is the number we've set, or the random use effect to have, then we show the random header message, which is fancy trying something new. So this is on page render. But what we're saying is that if it is more than 6, then we want to show the header message and say, check out these recipes below. So this is quite handy. We're also saying if results.length equal to 0, we want to show a no results message. And the no results message currently in place is, oh no, there are no recipes in our cookbook. We then map over the results component, which is the data, and then get each object, which we call recipe at the time, and then we return the recipe card information with all the relevant props and all these information like dairy-free, gluten-free, sort of missed ingredients count, price per serving, and the list goes on really. If I quickly go back to the slides, as mentioned here, we map through the recipe card component. And last thing to mention is that because we are passing through numerous data and making multiple requests to the API, we have used prop types to verify the data we are receiving.
Now I'll be talking about the recipe card component. Recipe card is a component in our app that renders inside search results where prompts are passed down. In each recipe card rendered, we have included information such as whether the dish is vegetarian, vegan, dairy-free, gluten-free, cooking time, price per serving, cuisine type, what occasion this dish is suited for, as well as missed and used ingredients. Due to the different types of requests made to the API, the information provided by the API to the recipe card will differ based on whether the recipe card is generated using the API's random endpoint or generated using the search by ingredients endpoint. Recipe card using random results will show all of the information mentioned previously, as you can see here. Some recipe cards will show all, and some will only show certain information. This data rendering is conditional, as some details are not available from the API. However, searching by ingredients will render a recipe card with only the used and missed ingredients information. So let's search these ingredients to see. Salmon, cream, cheese, and garlic. And let's click search. As you can see here, it's only showing missed ingredients and used ingredients in every single recipe card. To get a recipe's guide and information, another request to the API must be made. Clicking on a recipe card will trigger an onClick event that populates the ID parameter needed in the URL. Using async and promises, the response from this request is pushed into selected recipe state, which is in our app.js. Here is the ID parameter. Here is the response being pushed into selected recipe state. This is app.js, which contains this use state. This is then passed on as a prop into recipe info component using routing. Here's the route. This is recipe info component. This is the state being passed down as a prop. Recipe info component displays all of the extra information required to cook the chosen recipe. Here you'll find a section called key points, which includes whether the recipe is cheap, dietary information, number of ingredients needed, price per serving, serving portions, cooking time, and if it is sustainable. Recipe info also displays a summary of the recipe, a step-by-step guide, dish type, wine pairing, as well as full detailed instructions. Some headers on the page is dynamic. For example, the number of steps listed in the header changes depending on the step needed in each recipe. So we'll choose another recipe, checked the header, and it's now changed to 5. A lot of formatting needed to be done in order to display information in a user-friendly way. To make information on the screen dynamic, we used a lot of conditional statements to render information. The information provided is in JSON format. However, the values in each key value pair differed. Some were booleans, arrays of objects, as well as strings and numbers. Here you can see the booleans, numbers, strings, array of objects. Scroll down, pass all of this information, and here you can see some arrays. Functions have been created to process these values and output them in a readable and user-friendly manner. If statements, array instance methods, and math static methods have been used to achieve this. These functions have been separated from the component and placed in a file of its own folder and exported for reusability. So here are the functions that we use to format the data. They are then used in both recipe info and recipe card. They were imported here and used in the component. And here they are again.
So looking at the Foodle backend, as a group we came together and did a lot of research before we started doing anything else about what API we wanted to use, because that was very, very key for us. We wanted to provide as much detail as possible for the user, and we needed an API that allowed us to accomplish this. We came across Spoonacular, who pride themselves in being more than just a recipe API, and this really, really stood out to us. They provided touch points like ingredients, recipes, nutritional information, so allergy information, and they also provided a feature where it's search for the ingredients that you have in the fridge. And that was our core concept originally for Foodle. So we saw Spinnacular as as the perfect API to use. If I show you guys the platform quickly, so as mentioned, the only food API you ever need, that's what they consider themselves. And after using it, to be honest, I completely can vouch for that as well. We understand that nut-free muffins can't contain pecans, even if the recipe doesn't mention nuts anywhere. So they're also quite funny as well. So that always helps. The volumes of, information and data they provide, like over 5,000 recipes, ingredients, over 2.5k ingredients, use cases, stuff like sort of special diets and intolerances, nutritional information. So the scalability of this API is really what stood out to us as a group. And even if we did want to scale this, we could add so much to it through this API. If I go back to the presentation now, and I continue on talking about how we fetch the data and how we got the data. So we use Axios, and Axios is something we've used many times throughout the bootcamp, and throughout this project as well. It's really easy to use. Instead of using something like .fetch, where you have to kind of stringify the data, Axios does that automatically for you. And it also provides like a wide browser user support. And that's because it uses the XML HTTP requests under the hood, and sort of intercepts the data. We then manipulate the data using functions in React before presenting to the user. And the last thing to mention is that we use the .env to hide our API keys from any malicious users as well. So just going to go through some of the challenges. So like all things in life, there's always going to be challenges, and the Foodle application was no exception. I guess one thing to mention is that, looking at this, you might not feel like some of these are challenges, but as a group, we felt like, for us, these were kind of core challenges that we sort of overcame, and it's important to highlight that as well. It's not about, the fact that you come across a challenge, but it's also just as important on how you overcome that as well. So the first point I want to mention is the test-driven development. Of course, because of sort of the time constraints that we did have based on our priorities and our time management, unfortunately, we were unable to include some test-driven development in code, and we know how important it is right now in sort of the real world right now to test. So what we've decided to overcome that is that we are moving forward with this application anyway, and we are going to continue working on this after the bootcamp. What that includes is actually implementing some test-driven development, so some unit tests to try and break the code, some integration tests as well. So this is definitely something that we'll be applying at a later stage. Another thing I want to mention is the issues with the pre-formatted instruction text from the API. So of course, like every API, you're not always going to get the data exactly the way you want it. So it's about sort of how you sort of pre-format that or format that to the way you want. So what we did is we jumped on a call and we sort of mock programmed trying to figure out what the best way was to kind of format the instructions the way we wanted it. The instructions originally included some HTML text, and quite simply we actually applied a regex to remove that, and that seemed to do the job, which was lovely. And it showed that as a group we can come together and overcome any sort of obstacle. The landing page at the start but just only included the search bar, so sort of the main and the body area didn't really have much going on. So what we decided to do is also come together with sort of different ideas on what we could actually put in there, and we ended up going with a random recipe generator, which right now I personally think looks really, really good. So by seeing a random recipe before a user's even search, they can potentially just click on one of the recipes and actually already see a recipe that they like. Another thing to mention is that the API had to be fetched more than once due to the first fetch only sort of pulling in some core information like the title, the ID, the image, and sort of didn't come with the instructions. So in order to get the instructions, you had to make another request using the key, the ID, and then the API would pull in the additional information like the step-by-step instructions. Of course, this came across as a challenge because, of course, we had limited requests, and of course, we understand that scaling this would require the purchase of like an unlimited API package.
Our main aim for this project was to reach a minimum viable product, an MVP, which is what we strive to achieve. If given more time, we would look to incorporate a profile page where users could save their favorite recipes, even maybe let users rank recipes or vote them up or down. We would also look to maybe allow users submit a recipe of their own. We could even allow users to comment on recipes, and leave tips for other users who might be viewing the recipe for the first time. So this application really has a lot of scope, and given more time, I'm sure there's a lot more we could have done with it.